the multinomial logit model. First question is, do you need this model? Well, this model is typically taught at the graduate level, so if you're an undergrad, then this may not be applicable to you, or you might not have to go as far as looking at this model. If you've collected data from a survey, this model could well be useful. If you've come across the logit model, the binomial logit model, then this is pretty much similar. Recall that in the binomial logit, or just a logit model, that your response variable has one of two outcomes. Okay, where those outcomes, there's no natural ordering, so they're nominal. One silly example I did of this, video I did of this was date. Does a person get to date another person? Yes or no? So that's what I mean. So multinomial logit is an extension to the binomial logit because now your response variable has more than two outcomes. I'm going to focus here on interpreting the coefficients because remember, at the end of the day we are interested in either using the model for prediction or interpreting the coefficients to link the explanatory variables to see what the explanatory variables have to say about the dependent variable, the response. And we're going to focus on interpreting coefficients. So I'm not interested in coming up with a strategy to build a suitable model for the data. Okay, so what does the data look like? Here's an example taken from the SPSS example files so you can follow it. So pretend I'm a marketing company. I have three products: a cereal product, a breakfast bar, and an oatmeal thing, and I want to kind of see what factors influence people's choices of which kind of bars they go for. So my response variable is here, be fast, and you've got cereal, breakfast bar, oatmeal. So here we've got three choices. So we're supposing that an individual can pick one of the three, but not more than one. All right. Okay, and then we've got some explanatory variables. Notice that they are all qualitative or categorical. They are not continuous. So my interpretation of the coefficients in this case will be for qualitative explanatory variables. Okay, let's just show that it's been coded. Look at this value label. So if I press this, it should show us the codes used, like that. Toggle back. All right. So I'm going to kind of look at the how gender. See where the gender. Look at the interpretation of the coefficient on gender on the breakfast bar. So I'm going to ask the question: does your gender influence your choice of the kind of breakfast choice you go for? Okay. So how do we do it? Okay, we know we can't fit a standard regression model because my response variable is not continuous. We've just said. Nor can I fit a normal logit model because it has more than two outcomes. It's got three outcomes. Okay. Because that's an important point, let's just say this first person chooses cereal over when they've given a choice of cereal, breakfast, and oatmeal. The second person here, who is aged in this group 46 to 60, and it's a male person who's married and not active, goes for the breakfast bar. Okay, breakfast bar, just breakfast bar. And one more, let's do one more, fifth one. Oh, okay. Just happens to be also in the 46 to 60 group, also male, married, inactive as well, goes for the oatmeal. Okay, right. And notice, as I said there, each person only goes for one choice. Can't pick more than one. It can't be kind of greedy and go for more than one. So we'll ask each person, what is your preferred? What in the questionnaire it would be like? What would be your preferred choice? Oatmeal, breakfast bar, or cereal? Pick one only. That's what it'd say, something like that on the survey. Okay, So we have to fit a multinomial. As the name suggests, multi means many, nomial like nominal. So these are like nominal outcomes, they're not ordered. We can't say cereal is better than breakfast, we can't say oatmeal is better than the cereal, so on. Okay? Right, okay. Now, so let's do it without any bells and whistles. We'll just go Analyze, Regression, and then we'll look for Multinomial Logistic. Click. A window pops up, and I'll just reset it because I ran this through earlier. So we're faced with something like this. A dependent box, that is my choice, my response variable, so that's going to be the label BFAST for breakfast, so we'll take that over there. Now the factors here are any kind of qualitative things, whereas covariates, they're kind of continuous things. Alright, continuous x's, these are categorical x's. We're just going to have gender. Alright, that's it. And we're not looking at anything else, we'll just press OK. As usual with SPSS, you get a whole load of stuff dumped. We're interested solely on the parameters. So where is it? At the bottom, there you go. Let's look at it. Notice the box consists within it of two subtables. What goes down here is the choice. Now notice that one choice is missing. Remember we had cereal, breakfast bar and oatmeal? Cereal has been left out. Why? Well, the idea is that we're going to compare all these other choices relative to cereal. So if you think about dummy variables, when you did dummy variables, remember that if you have k categories, something k categories, you set up k minus 1 dummies. So here we've got a choice of 3, we set up 2 dummies, something like that. And likewise for the explanatory variable, so we'll look at each of these boxes. Each of these boxes will be comparing that choice to the thing left out, cereal. So this here box will be saying comparing people's choice of breakfast bar relative to cereal, and this one will be oatmeal relative to cereal. Okay, let's just take the first one for now. What we see inside here is we've got gender 0, gender 1. So let's go back to the, we need to know what is what here, so we click on this tab. Right, so we can see that male is 0, right, and female is 1. That's how it's coded. Go back to the output. Male, better to write this down, otherwise I'm going to start forgetting. Right, so male is 0, right, male is 0. Okay, male is 0. Okay, now, because gender has 2 categories, so k is 2, we leave out 1 as the reference category. So that's why you see that here, you see that gender equals 0, that has a number, that's the coefficient, but gender 1, that is set to 0, and then you've got a superscript b, which tells you that this parameter is set to 0 because it's redundant. In other words, it's basically it's set the gender 1, which is female here, to set it as the reference category. Alright, so gender, just to recap, gender is a categorical variable, it has 2 categories. Because of that, we set up just one dummy variable because of the rule, dummy rule. If you have k categories, you set up k minus 1 dummies. So this coefficient tells us then, we'll compare males to females and tell us something about how likely a male is compared to female to go for this option, the breakfast bar, relative to cereal. The interpretation is a bit like the binomial logit, so let's just recap that here. So if this coefficient on gender is, we need to consider 3 cases: bigger than 0, equal to 0, or less than 0. If it is bigger than 0, it would mean that males compared to females are more likely to go for the breakfast bar rather than cereal. If it is equal to 0, then males and females are equally likely to go for the breakfast bar relative to the cereal. And if it was less than 0, then males compared to females are less likely to go for the breakfast bar relative to cereal. Okay, and instead of looking at a b, we can look at the exponential of the b, which gives us the odds ratio. Alright, I think it's a good idea to write this down. Let me try and write this down. Let me lay it out. Okay, so we've got here, what am I saying? We've got the gender coefficient. Let's just call it b, so I don't have to write that again and again. And then we've got the odds ratio, which is given, it's this categorical variable here, as e to the coefficient value b. Alright. And we've said there are three cases. So result, let's say conclusion. Right. It can be bigger than 0. It can be equal to 0. It can be less than 0. But if it's bigger than 0, if you take e to a number bigger than 0, that's going to be bigger than 1. If b is 0, e to the 0 is 1. You can try this on your calculator. And if b is less than 0, if you put that into here, e to the negative number is going to be less than 1, but positive. Okay. The conclusion here then is to say that males compared to females are more likely to go for the breakfast bar than cereal. Likewise here, males females are equally likely to go for the breakfast bar, blah blah blah, same as go for breakfast bar and cereal. And here it's going to be males compared to females less likely to go for the breakfast bar and the cereal. Okay, right, so let's see what we've got here in this output. What we have got here is we've got coefficient of negative. Alright, so let's first of all get the direction right. So negative, that tells us, if we go back here, the coefficient is negative, it tells us then males compared to females are less likely to go for the breakfast bar and the cereal. Simple as that. Okay, how about if you wanted to say something more precise? Well, in that case you can report the odds ratio. 0.864. Okay, that tells us, let's write this odds ratio, 0.864. Odds ratio, that's going to be odds for the male group divided by odds for the female group is equal to 0.864. Okay. Now, if this figure, going back to this here, is equal to 1, you can see that odds for male is the same as odds for females, going for the breakfast bar compared to the cereal. Since this is less than 1, if you just multiply both sides, take this guy, multiply both sides by odds of female, we're going to get odds male equals 0.864 odds female. Okay, and this tells us that the odds for males is about approximately 14% lower than the odds for females to take breakfast bar and cereal. Okay, that last point there you might just want to kind of think why that is, but it may not be important to you, precise nature, as long as you get the direction right, which is more likely to happen. Just want to point out the interpretation here is for my explanatory variable, which is categorical. Okay, so let's just pause a bit so that let that sink in before we move on. Okay, there are going to be two other things I'm going to do here, related things. First thing, you might ask me, well look, I don't want to compare the breakfast, how likely someone is going to go for the breakfast bar relative to the cereal bar. I want to kind of compare a breakfast bar, so oatmeal. How likely is someone going to go for the breakfast bar compared to the oatmeal? Well, the simplest way to do this, well, involving no calculation, is to rerun it but set the reference category for oatmeal. Say I want to compare now breakfast bar to oatmeal. So I don't want the thing left out as cereal. We can tell SPSS that by rerunning it. So analyze regression, multinomial logistic. Okay, look, notice here, look, we've got reference category. We can choose which one it is. So at the moment it's set by default to last category. We want custom, and what we want to do is we want to set oatmeal to the reference. How do we do that? Well, first of all, we've got to get code for it. So let's go back to the data and just toggle. Right, so oatmeal, there's oatmeal in the third line. All right, let's just see what number that comes up when I press this button. 2. Okay, oatmeal is coded 2. So we go, it doesn't matter which window we do it in. We go analyze regression, multinomial logistic. This time I'm going to click on the reference category, and we're going to click custom, and we want 2 because we want oatmeal to be set as reference. Now before I press OK, you're just going to kind of guess what's going to happen to the boxes here. Well, are we going to retain breakfast bar? Yes. Are we going to retain oatmeal? No. Instead, that oatmeal should be replaced by cereal. Let's just see that happen. Yep, there you go. Breakfast bar and cereal. So if I want to compare breakfast bar now to oatmeal, look, for over gender, that's a negative number, so that tells us that a male compared to female is less likely to go for the breakfast bar than the oatmeal. Okay. I emphasize again in this video, I'm just looking at the coefficients here. I am not focusing on any of the test statistics. I'm not looking at significance. I'm not looking to see if the model is any good. I'm just assuming that this model is the best fit. Okay, now I just want to say that this odds here, 0.819, I could have got this same result from the first regression, so I didn't have to run a second regression. I could have just got it from the first regression, but then you have to do a bit of math. You have to write some numbers down, and I think that's not where we need to be. So we just want to kind of get the values out, but just know that if, say, you're in an exam, you're given this, you want to compare cereal bar over breakfast bar to cereal bar, and you want to calculate the odds, you can actually do that. You don't need to rerun this thing. Alright? Okay. That's the first thing. That's the first extension. The second one is, let me put this question to you. This result that I've got to get the odds ratio, did I have to kind of run a multinomial logistic regression? Could I have got the same result just running crosstabs? Because if you think about it, I've got two categorical variables. Choice of breakfast, which has got 3 things, 3 groups: cereal, breakfast bar, oatmeal, and then I've got gender. So isn't this the same as doing a test of association? Because once you've got the test of association, you've got the table, you can calculate the odds ratio that way as well, can't you? The answer is yes. So why don't we do that now, just to show you that I can get the same result. What I want to show you is, what do I want to show you? I want to show you that I can get the same odds ratio that we calculated here for males or females for going for the breakfast bar and the cereal using crosstabs. Okay, let's do that. I'm going to run crosstabs now. So that's analyze descriptives, crosstabs. Oh, by the way, before I run it, I want to say to you, it doesn't mean that you can just, if you want to do multinomial, that you can just do crosstabs, and I'll tell you why once I've done this. So you see why that multinomial is needed. You can't just do crosstabs instead of multinomial whenever you need to do multinomial. Okay. I just want to get these numbers, right? Because probably you can't see it that well, because one thing I don't like about SPSS, this table here, you can't really enlarge it easily and still make it look nice. Let me just write down the figures here. I want to bear in mind this 0.864. So let me just, while I copy the numbers out, you just kind of think about what we're doing here. So I've got the crosstabs table, it gives me male and female, and I've got a choice of breakfast bar, so type of bar, got oats, and I've got cereal, and then I've got the numbers coming in. So let's have a look. 104 there, 127, 155, 155, 165, and 174. And then let's calculate the totals. Okay, total number of males. Add those three figures up. 424. Add those numbers up. 4, 5, 6. Right, this is the crosstab. This is the crosstabs table. So it's saying 104. There were 104 men who took breakfast bar. Okay, and say here 155 ladies took oatmeal. I'm going to calculate the odds for breakfast bar over cereal bar. Okay, for men. Remember the formula. So how it works is like this. Let's see, notation wise. Let's change color. Let's go odds M for men. Alright, that is equal to the probability that they go for the breakfast bar, say breakfast bar, divided by probability here that they go for cereal. So we've got, to calculate probability that goes for the breakfast bar, 104 out of 424 go for that, so 104 divided by 424, that's the top line. For cereal, what proportion of them? Well, 165 out of 424, so 165 divided by 424, and recall that using fractions, the rule of fractions here, that divide is same as turning it upside down, so you've got 424 for 165. That cancels with that. So you've got 104 divided by 165, and that's for odds for men, going for breakfast bar over cereals. Do the same for females. So P breakfast bar over PC. Okay, ladies, breakfast bar 127 over 4, 5, 6, and cereal 174 over 4, 5, 6. Again, just using rule of fractions. Turn the second one to divide, thing being divided upside down. So we've got 127 over 174. Let's say that M F. Now let's go over here. The odds ratio here for men compared to ladies is going to be that M divided by that F. So it's 104 divided by 165 divided by this thing here, which is same as turning upside down, do times 127. Okay, now put that into your calculator. Okay, I've just done it on my calculator. I get the number 0.86. Okay, let's just go here. That's enough. Okay, that's the odds ratio, 0.8636. Let's go back up here. Oh look, 0.86. Well, 4. It's 3 decimal places. So the crosstabs is giving you the same result as running the multinomial regression. Wow. Huh. So does that mean that whenever we need multinomial logistic, that we can just run a crosstabs instead? Answer is no, no. Here it's fine, and the reason is because in this model, in this example, you see my explanatory variables are categorical. Remember, the crosstabs is a tool that can be used when my variables are categorical. So here I've got 2 categorical variables. The y is categorical, my choice of breakfast, and so is my explanatory variable. But the multinomial can also, we can have in the x's, we can have continuous things. For instance, here they've grouped the data age category, but if they had the actual age of the person, so this is continuous, then we could have put that in our model as well as an explanatory variable, as a predictor. Whereas you know that if this is continuous, you can't put that in, crosstabs couldn't handle that. So, to recap, a multinomial logistic model, is when your response variable contains more than 2 categories. In fact, if it's 2 categories, it would just collapse down. It would be just the same as the binary logit model. So it only differs from the logit model if the response variable has more than 2 outcomes. Okay, and if we think of them as choices, an individual going for one of those choices could depend on a set of explanatory variables, and those explanatory variables could be categorical, they could be continuous, or there could be a mix of them. And with this model, we can talk about, through the coefficients, we can talk about how the x's are related to the choices. We could actually also use the model to obtain probabilities of here an individual going for a certain choice. So when are you going to likely to kind of encounter such possibility of using such a model is like when you've got the survey data from a questionnaire and something that you're interested in is categorical with more than 2 outcomes, and those outcomes, that variable is nominal. It's on a nominal scale, so order doesn't matter. If the order does matter, then you would run an ordinal logistic regression. Okay, so you can have a go of your own dataset, or this dataset, which is an SPSS. It's called serial.sav. Okay, good luck.